We are looking at the strength of the soil, so how soil particles bind together. That is what we are testing in this lab right here using primarily this equipment. I'm Aritra Banerjee. I'm an assistant professor in the Department of Civil and Environmental Engineering. Now the problem is if you drive, let's say on I-29 or I-80, you will not have the same soil condition throughout. As soon as you change from one soil type to the other, now if you have a patch of expansive soil, that will shrink or swell, and that will create lots of issues with your pavement. And if we know that some soil is vulnerable for failure, then how do we stabilize that soil? That is what our research goes through. We can actually analyze how the civil infrastructure like embankments, levees, pavements, and things like that, how will they respond to different climatic conditions or stresses by themselves. Like the buildings start loading the soils, whether they will have chances of failure or how much will they settle. Temperature has an effect on the water content in the soil, so that is what we are mimicking right here, simulating different environmental conditions. So if it is drought, we can mimic that here. And then if there is rainfall, that can also be mimicked. And then we can study how the soil is responding to it. Basically, if it is expanding or shrinking, based on that, you can have settlements in your structure. If we allow water to go into those soils, they will expand. And when we have drought-like conditions, they will shrink so much, they will have cracks. We are actually inoculating bacteria or biofilms, which are microbial communities which are grown into the soil. And once they grow into the soil, they will increase the strength of the soil. That's what we are hoping for. With that, again, we are trying to find innovative solutions which may be sustainable for the future as well.